Hello friends, myself Rajendra Mahajan presenting my video on Laplace transform point solution of differential equation by Laplace transform technique. Let us solve the problem. Differential equation is d square plus 1 into y is equal to sin t, and conditions are y at 0 is equal to 0 and second condition y at 0 is equal to 0. These two conditions are called as initial condition, and that's why the problem is initial value problem. Therefore, we have to solve this initial value problem by Laplace transform technique. And therefore, here the given differential equation is d square plus 1 into y is equal to sin t, where that capital D stands for the operator of derivative d by dt, where d stands for d by dt. As already I had discussed this point, there are two parts. In the first part we are applying Laplace transform technique, and in second part we are applying inverse Laplace transform technique to get the solution. And therefore the first step is the Laplace of this left hand side and Laplace of right hand side, individual Laplace. Therefore it is Laplace transform of d square y plus Laplace of y and is equal to Laplace of sin t. Then applying the standard result, Laplace of derivative of second order is s square f bar of s, here function is y, therefore y bar of s minus s into y of 0 and minus y dash of 0. This is the Laplace transform of first term d square y. Then Laplace transform of that y, which is function of t, as y bar of s, and that is equal to Laplace transform of sin t, standard result a is here 1, s square plus a square 1 square, therefore 1 upon s square plus 1. Then collecting the terms of y bar of s in one bracket, we get s square plus 1 into y bar of s, and that is equal to, substituting the values of y of 0 and y dash of 0, both are equals to 0, and therefore this is 0, this is 0, transferring to right hand side, it remains 1 upon s square plus 1 only. Then dividing by s square plus 1, we get, therefore y bar of s is equal to 1 upon s square plus 1 into again 1 upon s square plus 1, and we call this equation 1. Here the first half part is completed, and after this step we require to find inverse Laplace transform by the known technique, either by standard result or by partial fraction technique or by convolution. Whatever applicable, use that technique. And therefore next step is taking inverse Laplace on both sides. Inverse Laplace of right hand side term 1 upon s square plus 1 multiplied by 1 upon s square plus 1. On right hand side we have product of two terms. Therefore whenever there is a product of two terms, we can obtain its inverse by convolution theorem. Therefore we know that inverse Laplace of the first term 1 upon s square plus 1 is sin t, and we call this as f of t. Inverse Laplace of second term, again it is 1 upon s square plus 1 and it is equals to sin t. We call this as g of t c. And then applying convolution theorem we get. Therefore applying convolution theorem, we have the inverse of this as, therefore inverse of y bar of s is y of t. It is integral from 0 to t f of u into g of t minus u du. And then from f of t we get f of u as, therefore it is integration from 0 to t, f of u is sin u and g of t is sin t, therefore replace it by t minus u, we get the second term as sin of t minus u and its integration with respect to u. Here it is the product of two terms of sine, therefore to apply defactorization, multiply it by 2 and divide by 2. We get 1 by 2 outside, integration from 0 to t. 2 sin a sin b is cos a minus b, therefore cos of a minus b, u minus this t, minus minus it becomes plus u, and minus cos a plus b, u plus this, and then its integration with respect to u. Simplifying it, we get 1 by 2 integration from 0 to t cos of u plus u, we get 2u minus t, and minus you get cancelled, we get only cos t, and its integration with respect to u. Integrating both terms with respect to u, we get 1 by 2. Integration of cos is sine of 2u minus t whole divided by 2. Integration of this cos t with respect to u, cos t is constant term. Integration of du is u. Limit from 0 to t. Substituting the upper limit for u as t, we get here 2t minus t means it is sin t only, divided by 2 minus u as t into cos t. These two terms for upper limit minus lower limit, u as 0, we get sin of minus t by 2, and this u as 0, this term becomes 0, therefore minus 0. We get 1 by 2 sin minus theta is minus sin theta, therefore this minus and this minus, it becomes plus sin t by 2 plus sin t by 2, we get sin t minus t cos t as a required solution obtained by Laplace transform technique. Therefore here the second part is completed. One more I will discuss in my next video. Please like my video, share it, as well as subscribe to my channel if you have not subscribed yet. Also press the bell icon to receive the notification for my all such type of new videos. Thank you. Thanks for watching.